Hello, I am Dr. David Kordowitz and welcome to Solidworks. Today we're going to be looking at the sustainability tools which are built into Solidworks. These tools allow us to consider our design choices and manufacturing choices to reduce the impact of our different designs on the world. Sustainability has become truly important in today's environment and manufacturing climate. Use of sustainability tools are key to better understanding how to manufacture as well as where to manufacture and to understand the constraints which are put on us with our designs. So let's begin. For today's lesson, we were going to be looking at this piston cam system that we've used in the past. If you remember, this is the one we used for the animation and motion analysis and shows us that we can spin around and change the piston position. I've gone ahead and assigned materials in here, and if we extend out our design tree, we can see that most of it's made of 1060 alloy, though some parts are made of aluminum and a few parts are made of other things. So this is plain carbon steel, and we have cast alloy steel and other forms of steel and aluminum for all of our parts. I'm going to go ahead and rebuild the document really quickly, and then we're going to take a look at how to do sustainability analysis. Just as a note, the sustainability tools built into SolidWorks are very powerful, however, are only part of the tools which are used by commercial entities. So if you go out and get a job working on designs, you're probably going to use some slightly more advanced tools for determining the sustainability and life cycle of your parts. However, the GABI system, which is used within SolidWorks, actually is fairly advanced and is the basis of some of the higher-end software. The first thing we're going to do here is go to our Evaluate tab and select Sustainability. Use of this tool will help us generate a report which we can explore and understand our parts. So the first thing we need to do is we need to look at what region are we going to assemble in. We can pick from North America, Europe, Asia, Japan, South America, Australia, or India. For the purposes of this study, let's start with North America. We can then determine how long our part is designed to last. So in this case, I have it set to 50 years. Let's set it to 20 years to start our study. We're then going to look at our use. So we can close this menu down and we're going to look at where are we going to use this. And let's say we're going to use it in North America in the United States. This device may need some energy while it's working, so we can check energy use over lifespan, and we can say that we're probably going to use electricity and how many kilowatt hours per year. Let's say we use 100 kilowatt hours per year, or that's actually a lot, so let's say about 50 kilowatt hours per year. We're then going to look at how does it get transported to, well, I guess we can also look at on our use, we can look at how long is it going to, we can look at how long we're going to use it for and things like that. But we're going to say that we're using about 50 kilowatt hours per year. We can close this down. Now we're going to look at how it gets transported. Now, it doesn't make any sense if we're going from North America to North America to run it by train or by ship, but we're probably going to use a train, and we're going to say that it's going to go, say, 2,000 miles. This is an average. We're looking at an average of how far it's going to travel, which would be 3,218 kilometers. This is roughly cross-country. Now, that's not to say that everything is going to go this far, but we can set it that way. The next thing we're going to do is look at what happens at the end of life. So right now it's set so 75% of the materials in this are going to be recycled. Now for a metal object like this, that is quite possible. I'm going to go on the low end and let's say that 50% is recycled. The next line is asking how much of our product is incinerated. And in this case, this type of device has nothing that can really be incinerated, so we're going to leave it at 0. Finally, the last part is how much of it goes to the landfill. And we're going to say half of it goes to the landfill because we're assuming there's going to be some grease inside the piston that's not going to make it difficult to recycle. So now we can look at the charts on the bottom. So right now we're going to say the duration of use, and let's say it is actually used for 20 years. So we set that. And what we're going to look at now is our actual usage. So we're looking at our carbon footprint, and our carbon footprint is somewhere around 3,000 units. Whatever that unit is, we can click on it and it will give us more information in terms of how much is used in materials versus manufacturing versus use, and things like that. So right now we're using somewhere on the order of 20,000 of 2,300 kilograms of carbon dioxide to create our product. This isn't necessarily a good thing, but I think it's important to look at everything together as we as part of our overall determination. So we have other tools available to us as far as other potential units and other potential setups. So we can go back to our home, and now we can look at how much energy is used. Right now we're using somewhere on the order of 4.7 times 10 to the fourth megajoules. Most of that's going to be in the manufacturing of the materials used here. A lot of it's also going to be used in our overall use. We can go back, we can look at our air and water usage while we're developing our product. Now, it's also important to note that if we look at our graphs here, we have one that's in red and one that's in green. We have our current settings versus our previous settings. So let's say we're actually only going to use this for 1 year. When we do this now, it's going to recompute everything based on the 1 year usage. Now, you're going to have certain costs that are fixed, such as the actual construction of the device, where you're going to have some other things that are flexible, such as materials used during usage and things like that. Additionally, if we change the location where things are assembled, so let's say instead of building in North America, we say, okay, well, let's go ahead and manufacture in, say, India. Things change when we change where we manufacture. So we're going to change it to India. And what we find is if we go to India, we have to change our transportation, which is automatically done for us. But what we notice now is that the carbon footprint has gone down, the energy usage has gone down by 1%, and the air usage and water usage, though, have gone up. Additionally, the financial cost of our product has gone from $18.20 from previously from $363.20 to $18.20. So you can see the change of going from manufacturing in the US to manufacturing in India significantly lowered our cost of manufacture. However, it increased our environmental impact. So now that we've gone ahead and done this, once everything is done, we can go down to the bottom of the screen here and select to generate our report, to save as. This will generate our report in a Microsoft Word format. So we can say, generate a sustainability report. We have the ability to generate it as a spreadsheet or to do it as Gabby input software for if you have the Gabby suite. So let's go ahead and save this as a general report. So I'm going to go ahead and hit the OK button. And what it's going to do is it's going to recompute everything and it's going to save it out into this Word document. So now let me open that Word document. I've gone ahead and opened this Word document, which has been generated, and it's in the same folder as our model. When I open it up, because I haven't set the defaults in Solidworks for my company or company name or address, these are just sort of put in as filler. So if you want to go ahead and add additional information, you can go do it simply by clicking and replacing the text. Our report shows us a picture of our device. It shows us the weight, which is 12 kilograms. It shows us how long it's designed to last and how long our models are using it for. In this case, we've manufactured our device in India and we are currently using it in Europe. As we continue forward, we're provided information such as where it's created, what type of energy are we using, to manufacture, as well as what are we using when we're actually using the device. So in this case, we're looking at 1 year at 50 kilowatt hours. As we continue down, we have our transportation as well as our end-of-life information, such as what happens to our materials when our product is complete, use of it's complete. As we continue down, we have our environmental impact, we have our carbon footprint, our total energy consumed, air acidification, and water eutrophication, which is basically telling us what our environmental impact is. We break this down in terms of the materials used to build the device, the manufacturing of the device, the use of it, the transportation, as well as the end-of-life effects. This gives us a ratio so we can sort of look at how these things work. This is telling me that our overall financial impact is going to be $18.20, which is pretty good. As we go down here, it's going to give us more information about where our impacts are. So for example, our bracket, which is holding together our entire device, is using the most energy of the entire device. This is done by ratio of mass and what each item is made of. Our least is our axle. So obviously our axle is a little tiny thing, so it's not using very much in terms of energy. It's not messing up air too much, and it's not adding much carbon. In addition, this report provides us with some views so that we can look at it, and also gives you the ability to take notes and change the units and recalculate the report as needed. So basically what we've done is we've generated a report. It has a glossary which we can give to, say, someone who is one of our clients to show them what the environmental impact of their design is and how much things are going to cost. This is actually a very useful tool if you'd like to understand sort of the overall impact and understand the worldwide sustainability of your designs. This concludes the Solidworks course. I would like to thank you for the time that you've put into learning Solidworks with me here in this video series. If you intend to continue with Solidworks, remember to practice the skills that you've learned, as well as learn how to apply them in new situations. In addition, if you wish to take the CSWA exam following this course, make sure to go and take a practice exam, which is available through the virtual tester application. This will get you used to the methods as well as the format of the examination and the time constraints which are going to be imposed on you while taking the exam. Again, thank you for your time, and hope you enjoy using Solidworks for your future projects.